Hello, sixth graders at West Platte Elementary School. Mrs. Parsons here, your sixth grade math teacher. And today I'd like to share with you a video covering the review of geometry. We're getting ready to take some assessments here at West Platte, and we just finished our first unit. And in that unit, we had geometry and some algebra. And in those two concepts of geometry and algebra, which really aren't concepts, they're actually forms of mathematics, inside those things, we covered a lot of material. But in those material items, or items of material, we had some basic math operations and things that we needed to know or should have known in order to incorporate them into the concepts we were going to learn in sixth grade called geometry and algebra. So today's video is just a big review, as in, it's going to be a video that's big, a big review over geometry. And I'm going to cover 4 items. I'm going to cover area, surface area, nets, and formulas. Now, as I say those are the items I'm going to cover, I also want to remind you, sixth graders, that in your Google Classroom, you have some review and study guides from Mrs. Parsons, showing you some very important information. So I'm going to minimize this screen down, and I'm going to bring up that screen that you can locate in your Google Classroom. And it's really not a screen. It's an actual Google slide presentation that has a bunch of notes in it that we either took in class or that you took or that I provided for you. So when you open up that Google presentation where you're studying, it's a whole study guide. You'll see, of course, my opening Mrs. P's Mathmania page. And then you'll see a page that talks about the terminology for geometry. And all of these vocabulary words are words that we covered when we were studying the unit of geometry and algebra at the beginning of school. And of course, there are things like 2-dimensional figures, 3-dimensional figures, the area, a polyhedron, a prism, faces and edges and vertex, and surface of area and nets. And in this video today, I'm going to touch on each of those lightly in my video, hopefully so it doesn't run too long. I then have some notes for you that we actually took in class in our math folder about finding the area of rectangles and triangles and parallelograms. And then we also talked about finding the surface area of those figures, that once we took them from 2-dimensional and turned them into 3-dimensional, how do we find the area of those items? And then I also gave you the formulas of each one of these items that we've talked about. Squares and rectangles, parallelograms, and triangles. Remember, there's not a formula for polygons because polygons are made up of other figures, kind of like we work with the combination of creating an object where that polygon has a rectangle and a triangle in it, or other kind of items and figures. Not other items, but figures or shapes. So those are our combination of figures. And so there's not really a formula for it, but I'm going to actually touch on it today to show you how you can kind of remember how to find the area of a polygon, and then how do you use that when you're trying to find the surface area. I then went ahead for you sixth graders, and I broke down each one of these major figures that are new to you, such as the parallelogram. It's not like a square and a rectangle that you learned back in the 4th grade. It's a new figure. So I discussed that with you in your Google Slide classroom presentation. I also talk about the triangle, and I talk about the polygon. And you can go through all those notes, and I also printed out a study guide for you and sent that home with you as well the other day. So now, sixth graders, I'm going to go back to my lovely presentation here where we're going to cover area, surface area, nets, and formulas. And I kind of look down a little bit, sixth graders, because I have my whiteboard in front of me, my rolling white card, and I have all my notes. So I, 1, stick to it so it doesn't run long, and 3, so I don't forget anything. I don't know if that was 2 or 3. You get the picture. So the first thing I'm going to discuss with you sixth graders is area. So I'm just going to make a whole new slide for it, and I'm going to write that word down. And so the first thing I'd love to do is I want to kind of define area for you in just a shortened version that's kid-friendly, so you're like, oh, I know what that means. So I want you to remember that area is that which covers a figure. It is the surface between what you guys would think is the perimeter or the boundaries of the figure. So if I have a figure, and I'll make one just here on the board for me, If I want to find the area of this object, it is not what goes around the object. That is what is known as our perimeter. That's the boundary of my square. Area is what covers the surface of that square, or it's what lies in your perimeter and boundaries. It's not what goes inside like a three-dimensional figure volume, but it is what covers the inside of your boundary. That is how you find the area. And in order to do that, you must have some dimensions. And in this case, for a square, a flat surface object, you must have 2 dimensions. You must have 2 dimensions. And that's why it's called a 2-dimensional object. You must either have a length, a width, or a height of the figure. And you just need 2 of those. And once you find those 2 dimensions, you can always find the surface area of your figure. As long as sometimes you know exactly how the figure works with its dimensions. So in this case, I'll just use this square. And I say to you that it has a length, and the length's going to run across for me in this one. I'm going to say it's got 10 feet. And if it's a square, if it's a perfect square, then it should be 10 feet here as well. And for me to find the area, what covers this square, I simply take the 10 by 10 and I multiply it. And in this case, it would be 100 feet. And that measurement has to be squared. And why does it have to be squared? Because 6th graders, there's actually, and I'll use a different color, 10 feet that run along here. 4, 5, I don't know how many I have, 5, 6, 7, 8, 9, 10. I kind of went back and did them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's actually 10 feet that run up and down. That is what this 10 feet is. There's 10 feet right along here. So every foot I can make a mark. Then 6th graders, along this side, there's another 10 feet. So I'm going to go sideways. 2, 3, 4, 5, 6, 7, 8, 9, 10. And now 6th graders, if there's 10 feet here and I mark every foot, and there is 10 feet here and I mark every foot, there are going to be 100 little square feet inside that square. That means that each one of these is 1 foot. And I'm going to use a different color. Each one of these is 1 foot by 1 foot. And that's where I get the 100-foot square. And that is how we find the area of a figure. We then look at it and say to ourselves, how do I look at the dimensions and how do I know what covers that area? And so, or that figure with the area. And so you simply do the multiplication, find your 2 dimensions, whichever ones you're going to use. In this case, I can say I use length and width. If it was flat and I was looking back, it'd be width. If it's standing tall, I could say it was the length and the height. As long as I use 2 of them, and in this case they're the same, but in other figures they may be different, okay? That is how we find the area of a figure. And it depends on what area of figure we're finding. I'm going to go back to that little diagram that I had earlier. Each one of the figures has a different formula. Here's another piece. The square is just take the side by the side. The rectangle is the length times the width. A parallelogram is a base times the height. And a triangle is base times the height, and you take half of it. The key point about formulas, 6th graders, and the figures you use, you don't have to memorize them. They're given to you. As a test, or on a test, or as a teacher, we will give those to you. You don't have to memorize those any longer. You can just find them. But if sometime in your life you become something, a designer, or any of those items as a job, you might want to start to memorize those. You might want to start remembering what those formulas are. But the important key here is for you in geometry is you're not going to remember these, or you're not going to have to memorize these. They'll be given to you, but you do have to know when you're looking at figures, what figure am I using, and then how will I fill in that formula? This was a square, so we said side by side. If I draw another figure, And remember, I'm not the best artiste. And it looks like this. This is a parallelogram. Ooh, you can barely see that. Let me darken that up. This is a parallelogram. And so 6th graders, as you can see, it's not a side by side. You can't take side times side because then you don't have equal sides. And in fact, you're not really for certain about this side because of this lovely angle that runs here. So you'd have to go back, 6th graders, and look at your formulas that you have for a parallelogram. And it's important that you know how to fill those in. So I know that the area for a parallelogram is area equals base times height. So I have to find my base. I'm going to say my base is right here. And that base is 12 inches. And then I have to find my height. And when you're finding height of a two-dimensional object, you must find a 90-degree angle in which to take its exact height from. So that is why we use this thing right here called a vertex. And we go from that vertex all the way to the base. And that tells us then, ladies and gentlemen, that there's a 90-degree angle here. And I can put it on the inside if I want. And if I can find that 90-degree angle, then I can remove this piece of triangle fictitiously. I'm not really moving it, but in my mind, I'm going to move it. And I'm going to put it over here. And when I do that, it will fit perfectly into a figure I already know that I can find the area of, and that is a rectangle. And then once I know what this is right here, which is the height, and I'm going to say it's 8 inches, I can then multiply those two things together and find the area of my parallelogram. And in this case, it's going to be 96 inches squared. Again, all area needs to be squared. When it's just standard area, it all needs to be squared because that means there are that many lines going across and that many going up and down. You must always square that. So that's how we work with area. And we do that by knowing the right formula. Things that you're not going to have to memorize, but things you're going to have to realize, oh, that's a parallelogram. Oh, that's a polygon. Oh, that's this, that. You have to be able to identify those shapes and then ask yourself, what formula am I going to use and how do I know how to fill it in? That's a very important thing for you to know when you're studying 6th graders. So, there's a few things I've covered them. I've talked about area, and now I've talked about your formula. And knowing that you're going to have to pick which one to use by the shape and the figure you identify, and then you must fill it in by knowing the dimensions that are being used. And then, of course, that all happens when we use the mathematical process in basic operation of multiplication, okay? And that can happen with whole numbers, fractions, or decimals. Now, I want to move on to surface area. When I talk about that, I'm hoping to touch on the nets, and then that way, hopefully I'll wrap up this video for you. So I'm going to touch now on surface area. A little bit ago, we just said that we could find the area of this square. Okay? We said we could find the area of that square by finding the two dimensions that make up that area of that figure. So I'm going to say this is just 8 meters. Okay? Well, if that side's 8 meters, then this side is also 8 meters. Now, we can find the area of this very easily. Just multiply the sides. 8 and 8 is 64 meters squared. But that is the area of a flat, two-dimensional surface. We can decide what formula to use. In a square, we go square times square, which we now know we use the dot, so square times square, or it's really just, or I'm saying square, I mean side, side times side, or it's side square. That's the formula of the square. Again, we can find the formula that we need to use for whatever figure's in front of us. But what happens, 6th graders, when, and I don't know why that keeps popping up. Let me get rid of that. Oh, I went back too far. Let me go back to my shape. What happens, 6th graders, when we turn this two-dimensional figure into a three-dimensional figure and we want to find Not just the area of that square, but every square that makes it up. That is what is known as surface area. And of course, I'm going to draw out a two-dimensional figure here. Bear with me in my fancy drawing. I'm going to draw out a two-dimensional figure. Let me draw it out the right way here. Would be nice, right? Let me see if I can do that. Not the prettiest, but again, you get the idea. When I have a three-dimensional figure, it goes from two-dimensional to three-dimensional. What do? Well, I'm still going to try to identify what figures I'm using, sixth graders. And in this case, I know I'm using squares. It started off as a square. It still is a bunch of squares because we know this thing is called a cube. And if I want to find more than just the area of the front of that cube, I don't just want to find one square. I want to find the area of every square. That's what's going to be called surface area. And a quick and easy way to remember that, sixth graders, is make sure you've got every figure covered. So what I like to tell students when they're trying to find the area of figures, especially when you're trying to find the surface area, use what's really not a formula, but can be helpful for you to use like a formula. You know that every three-dimensional figure must have probably a front and a back. So here's my front, there's my back. It must have a top and a bottom. This is my top, that's my bottom, and it has a side and a side, side and side. So in finding what you know as a surface area, first ask yourself, what's the figure? And then find the area of one of those figures that you're putting into a group, like a partnership. Find the area of the front, you can get the back. Find the area of the top, you can get the bottom. Find the area of the side, you can get the other side. If you can find one of those pieces, then you can do what we call a multiply by 2, and then you'll get the front and the back together. By 2, and you'll get the top and the bottom together. By 2, you'll get the side and the side together. And so in this case, I knew that the front of my cube was 64 meters squared. So what I can do is I can multiply that by 2. And ladies and gentlemen, that's going to be 128 meters. Oop, and it's not cubed anymore. Oopsie. Oh my. It's not cubed anymore. Well, this is still going to be squared. Hang on a minute. Let me write this. 128 meters squared. That's going to be squared, 128 meters squared. And then once I find all the surface areas, then I'm going to put those together. So out of this cube, I have 128 meters squared. But that's just for the front and the back. This is nice because it's a cube. So if the front and the back are 128 meters squared, then the top and the bottom and the sides are too, because it's a perfect square. So I can just add 128 3 times, because this is going to be the front and the back, the top and the bottom, the side and the side. I add those things up, and I get that it's 384 meters squared. Oops, yes, squared. And I just erased it again. 384 meters squared. Why is it squared? Because you still then found the area of all of the surfaces in that lovely figure, sixth graders. So 384 meters squared. And now that means that here there's 128, well, 64 in the front, 64 in the back, that's 128. There is a 64 on the top, 64 on the bottom, 64 on the side, and 64 on the side. And that's how we find the surface area. And then we just add all these things up, and that gives me my total surface area, which we will not forget to square. Okay? Last thing, before I can let you go in the video, are nets. So now, sixth graders, if I were to get rid of all this information, and I was left with just this square, which part of those squares, the screen just puts them on there. If I took all this away, and I'm going to actually go ahead and make a new screen for it. If I took all this away, sixth graders, and all I had left was my lovely three-dimensional figure back again, how could I tell that that three-dimensional figure was that actual three-dimensional figure? And what we can use is what is called a net. It simply means take a three-dimensional figure and break it down into its two dimensions. So I just want to unfold that three-dimensional figure. So I know the front is a square. Oh my goodness, Mrs. Parsons. I know the front is a square. So that's this right here, covered. I know the bottom right here is a square, so I'm going to add it on. Again, not very pretty, but you get the gist. And then, so that's the front. It just folds out. The bottom stays. The back is going to drop down. There's the back. And the top is going to fold over and be added to the back side of the box. Well, the only thing I don't have left, sixth graders, are the sides and the sides. So I'm just going to have them drop down right beside the bottom here. So this is my front, my bottom, my back, my top, my side, my side. And then that tells me that this really is a cube because it's made up of 6 squares and it's a three-dimensional object. And why is that important, sixth graders? Because you need to see where the faces, the edges, and the vertex are so that you know where the dimensions are on each figure. You can then tell, oh, this is 8 by 8. Well, if the front is 8 by 8, then the back is 8 by 8. Oh, this is 8 by 8. And if the side's 8, this side's 8 by 8. And if the back or the bottom here is 8 by 8, then the top is also 8 by 8. And it allows you to put the dimensions in the right spot, sixth graders, so that you can then find the area of each of those two-dimensional figures. And then you can add the front and the back together. And then you can find the two-dimensional figure area of the top and the bottom, and you can add those together. And then you can find the area of the side and the side, those two-dimensional figures, put them together. But you really need to know what dimensions go with each one. And that is what a net helps us do. So let me look here. Did I cover the area, that which covers the figure? It's the surface inside the perimeter, the boundaries. Check. You've got to pick what formula you want in order to find the area of a two-dimensional figure. Surface area. It's all the sides added up, okay? Remember, look for a figure you know in it to help you out. Next are two-dimensional figures that you can fold back up to three-dimensional figures, or three-dimensional figures you can flatten out to two-dimensional figures. They have sides, edges, and vertex or faces. So the face right here, that's a face. That's a face. I'm going to write it on there. That's called a face, what you look at, the flat surface. This thing right here is called an edge. And this thing right here is called a vertex. The face is the flat surface you see. The edge is what connects the items together, the figures and objects together. And the vertex is where those edges meet. Covered those. And then formulas again, you'll have to pick which ones you want to use. So I ran a few minutes over. I wanted this just to be 20 minutes. It's going to be about 25 minutes. But I hope that just kind of gives you a quick, fast review of how to find area, how to find surface area, how to use nets, and how to pick the right formula to use when you're trying to find all these things in the lovely math, the actual math practice known as geometry, or as Mrs. P likes to tease sometimes, geometry. Well, I'm not really a tree, I'm a person. But anyway, you get the idea. Enjoy the video. Study all the other documents I've put in your Google Classroom to study. And hopefully everything will go great. This, which is what, Wednesday today? Well, it'll be, Wednesday. Everything will go great Wednesday. And you'll be fine for your test on Friday. So until I see you tomorrow with another video, adios and have a great day.